Hello guys, so we have a problem here under physics, and this problem is associated with the topic work, energy, and power. Now the problem is this: a bullet fired at a wooden block of thickness 0.15 meters manages to penetrate the block. If the mass of the bullet is 0.025 kilogram and the average resisting force of the wood is 7.5 times 10 exponent 3 Newton, calculate the velocity of the bullet just before it hits the wooden block. So this problem, to find the solution to this problem, we need to use what we call the work energy principle. The work energy principle. Now, let me explain what this question is exactly all about. Now, think of um, a wooden block. Just think of a block in which a gun is fired at, and the bullet strikes the block and penetrated into the block. Right now, when the bullet penetrates into the block, the velocity stops. That's the final velocity becomes zero. Right now, this question, what we are asked to calculate here is the velocity of the bullet just before it hits the block. You understand? Not the velocity after hitting the block, because the velocity after hitting the block is going to be zero, because once it hits the block, once a bullet hits an object, it stops, it doesn't move again. So final velocity becomes zero. But what we are asked to calculate here is the initial velocity before it hits the block, right? So to solve this problem, we are going to use what I said earlier as what I called earlier as the work energy principle. Now, the work energy principle is this: work done is equal to force times distance, and force times distance itself is equal to half mv squared, right? So work done is equal to force times distance and also equal to half mv squared, right? So we can deduce this as saying that force times distance is equal to half mv squared. Now, what this is called the work energy principle. Now, what this means in respect to this question is that the resisting force, the work done of the resisting force of the wooden block is equal to the initial kinetic energy of the bullet, right? So this is where um our problem is coming from. So here we have velocity here, which is actually what we are asked to calculate. So from the question, let us determine the given quantities from the question. So force, the resisting force is equal to 7.5 times 10 exponent 3 Newton. I want us to convert this to ordinary number for easier calculation. So this would be 7,500. If you convert this standard form to ordinary number, to become 7,500. Now, our distance, the distance is the same thing as the thickness, is the same thing as the thickness of the wooden block, which is 0.15 meters, right? Then our mass of the bullet is 0.025 kilograms, right? And then the velocity is unknown. That's the initial velocity is unknown, and that's what we are actually asked to calculate for, right? So if we substitute these quantities into the formula, we will have that F is equal to 7,500 times distance, which is 0.15, right, equal to half 1 all over 2 times mass, which is 0.025 times v squared, right? I'm going to be making use of this area because of space, right? So from our calculator, we have that 7,500 times 0.15 is equal to will be equal to 1,125, which is equal to 0.0.02 0.025 times 1 is still 0.025 divided by 2. That will give us that will give us um that will give us 0.0125 v squared, right? Then we make v squared the subject formula. Making v squared the subject formula, we have that would have that v squared would be equal to 1,125 all over 0.0125. So let's divide this. Dividing this, we'll have that 1125 divided by 0.0125 should give us 90,000. So v squared will be equal to 90,000, right? Making v the subject formula, we have that squared comes over here. We have root 90,000, right? So root of 90,000 will give us 300. So therefore, velocity, the initial velocity or the initial kinetic energy, or the initial kinetic energy or the initial velocity will become 300 meter per second square. Sorry, 300 meter per seconds. Yeah, per seconds. So that's the final answer.